All right, for this next segment, you will need to have a graphing calculator. So on my website, under this lesson, Lesson 17, there is a website that will direct you to download the emulator. And the emulator looks like this. I'm using the emulator. This is the one I use on the computer. Or you can simply, if it's during class hours, you want to use the calculator, just let me know, and I will have them available. They'll be showing up, a box of calculators will be showing up in the for this particular unit and the next unit. So correlation coefficient, continuing on with the lesson here. As you look at this note, I talked about being able to determine whether it's a strong or a weak relationship. So in order to numerically measure the correlation of a relationship, mathematicians define covariance of two variables as. So covariance meaning their relationship or the strength of relationship with each other. So let me get through the explanation here. The formula here, remember that small s means standard deviation. So we are looking at the standard deviation of two variables. Deviation. So we are looking at the standard deviation for the variables x, y, and here's the equation or the formula. So the value of x is the data point in question. Your x bar is the mean of independent data. So values on the x-axis. The y value is the data point resulting. So it's your independent variable. So it's the y value that was associated or tied to the x value in question. The y is the mean of dependent data. And n is the number of data collected. So there's the variables, and you're looking at it thinking, oh, okay, this isn't going to be too bad. You can use a spreadsheet for this. I'm going to even make your life that much simpler in telling you that, you know what, you're never going to have to do these calculations because I'm going to always provide you with technology. I could make you go through and do the calculation and use this formula, so you do not need to put this on your cheat sheet. There's no sense because you're never ever going to have to do this by hand. If you're stranded on an island, who cares about the correlation factor? You're going to be able to download a graphic calculator or emulator. You can use spreadsheet technology. I'm incorporating the calculator because the calculator actually works fairly efficiently for this particular section. So the correlation coefficient, this is what we're really concerned with here. Correlation coefficient, and the variable for it is r. Is calculated using this formula. So it is taking the covariance of what we just calculated from above. This is your standard deviation of x. So standard deviation of x. This is your standard deviation of y. And that kicks out a value of r. So r, I'll just put it over here. The value of r is our correlation coefficient, and it tells us how strong is the data. And that's what we're wondering about. And like I said, in grade 9, I made it fairly obvious or exaggerated it. Here, it's not so easy to determine the difference between them, so we need a numeric value, and the value of r will do that for us. So, what I'm doing here is I'm creating a number line, and in the middle, I'm going to put the value of 0. If your r value, and this is your r values, so I guess I'll put r equals. If you get an r value of 0, you have no correlation whatsoever. So if the calculator says r equals 0, you have no correlation. That means that you should not be using this as a mathematical model. If we move to the right of this, to the positive values, what we end up with is what we call positive linear correlation. Okay, and this is going to be very important. You want to make sure you highlight this for the note because this is going to come up in the project specifically when you're talking about relationships that exist here. So we'll split this into thirds then. So if your R value is 0.33, 0.66, or 1, what we call those particular regions is weak. So it's a stretch to use a linear relationship. Here we would call it moderate. So the relationship is there, but it's not overly strong. And then finally, if you move above 0.67, you're dealing with a strong all the way up to a perfect relationship. And you're going to find some of the homework in the textbook is pretty close to perfect, but again, they're making you practice with it, so there's reasons for their idealism. Going the other direction, it is a negative linear correlation. Hey, and make sure when you realize when I'm using the word positive, that's referring to the slope, okay? Same thing here. So if it's R is a positive value, that means it's a positive slope. Negative values means a negative slope. So that word is key. It is telling you something. So negative 0.33, negative 0.67, and negative 1. So again, same increments or same breakdown. We have weak, we have moderate, and we have strong. Just because it's a strong negative, it just tells you the slope, that it's a decreasing relationship. So it's okay to have negative R values. It's the closer it gets to negative 1, the better the relationship. It just tells you that in this case, the line is going to look like this, or the data is going to trend like that. Over here, the data trends upward. All right. So I have the first example up here. Before I get into the example, I'm going to have to show you how to use the calculator. So the graphing calculator, you need to turn that on. And when you are doing this, you want to hit the following buttons. So you want to hit second plus 712. You want to reset the memory. You want to do that always. All right. Next, we want to turn the analysis tool on in the calculator. So you need to hit second again. And now you want to hit 0 because we want to get into the catalog option. And we're going to have to use the up and down arrows here. And we're going to scroll all the way down to, we are looking for diagnostic on. All the way down to diagnostic on. Once you found it, you hit enter. And you hit enter again. And the diagnostic mode is on. Next, and you got to remember this for a test and for the exam, how to use the calculator, you need to hit second again, and now you want to hit the y equals button because we want to be able to turn the stat plot on, so you want to be able to tell it, hey, I want to create a scatter plot, so show the points for me. Once you've done that, and made sure you hit enter and it's flashing on the on, you can then quit. Okay, so now we're ready to go for our example here. So the example, a farmer wants to determine whether there's a relationship between the mean temperature during the growing season and the average of his wheat crop. So we have the following data in the chart, and we're going to enter that data into the graphing calculator. So we're going to hit stat, the stat button, and we're going to edit. We're going to put that T-chart into our calculator. So the L1, L2, L1 is the X value, and that's the mean temperature. So the mean temperature is our independent variable, and the dependent variable was what the yield was that year. So I'm going to enter those in. So 4, 8, 10, 9, 11, and 6. Using my scroll, I'm going to go up and put in the corresponding yields. So 1.6, 2.4, 2.0, 2.6, 2.1, and 2.2. Okay? Now before creating a scatter plot, I'm going to go to the window button. And the window button tells me what my x and y values are going to be. So if you hit window, it tells you your x min. So if I look at my data here, my mean temperature, the lowest number is a 4. So I'm going to say, well, my mean temperature is going to be a 0. And then my max, if I look at it, it goes up to 11. So I'm going to go up to 15. I'm going to pick something a little bit bigger. My yield, it goes from 0, and the largest yield there is 2.6. So I'm just going to go up to 3. What this does is it produces a graph that's specific to the information you're given. And you want to make sure your window's set right, so when you hit graph, and you're going to hit the graph button, the data points are all there for you. Okay? So looking at the question asked here, determine the correlation of the data and determine the correlation coefficient. So what we now do, we go to our stat button. So you hit stat, and we're going to go to linear regression. So I'm looking at option number 4. And that's because we're in the linear regression section. So if you just stay there with your calculator, I'm looking at the graph, I'm looking at the data, and when I'm looking at it, I see that it does kind of form a line. So I'm going to try that. So I'm going to see, does it actually give me linear regression here? So if I hit enter and hit enter, this is what comes up. So the equation then, and I'm going to bring this in so I can talk about it. I want to take a screenshot, and I'll see black and white only. Go in here. I can not paste it. Okay, it was a good try. So anyway, I'll keep that up. So if I look at the equation, I have the equation is y equals a, which is my slope, 0.062 x plus my b value, which is 1.66, and my r value, I'm only worried about r, is 0.47. So when I look at the analysis here, 0.47 on our slide scale means that it is a it's in the weak category, or sorry, moderate category. So there is a moderate relationship. It's positive, and that makes sense because when we look at the graph, it had a positive slope. So to answer the questions here, A part, determine the correlation in the data. I would say there is a moderate, so I'm commenting on strength, a moderate positive correlation. So there is a relationship there, but it's moderate. I don't want to hang my hat on it, but I can't dismiss it. B part, I already answered that. R equals 0.47. And C part here, determine what conclusions can be made based on your results. And it's exactly what we said. There is a linear relationship. I'm going to run out of space here. However, so, oops. I want to get rid of the ink layer. It's going to be a little bit frustrating, but however, there must be other factors to consider. As the relationship only has moderate strength, you could say. All right, so there is a relationship that exists there when you're looking at the data, but when you are analyzing it, you realize that that 0.47, 0.5, it's still in that moderate region. So yes, there is a relationship. It's not a overwhelmingly strong relationship, but that R value now takes away your guesswork that you had in grade 9, and you can definitively say, yes, we have a strong relationship, weak, moderate, and so on and so forth. And you can put a numeric value to it now. All right, I have one more example to get through, and it's just using the graphing calculator similar to this. And we'll see you in a minute.